Hello and welcome back to Get Kafka-Nated, a show where we explore the fascinating world of Apache Kafka, from architectural deep dives to the people who make it all happen. Hi, I'm Hugh, your host, and I'm excited to be back with you for our 6th episode. As always, we've got a coffee on us for our live audience. You'll find the link to claim your voucher in the chat. Quick reminder, it's currently only available in Europe and North America, sorry about that, but we're working hard to expand this globally for future episodes. Today we're exploring the powerful combination of Kafka and Apache Flink, two technologies that together are transforming how organizations handle real-time data processing. I'm delighted to welcome Ververica Field CTO Ben Gamble. Welcome to the show, Ben.
Hi Hugh, great to be here.
So let's jump right into it. You've been working in the streaming ecosystem for a while. What first drew you to Flink as a technology in particular?
So it kind of actually came back as I rolled right the way back. It was about 2017, I think, at the time. And I was CTO of a logistics startup at the time. We had event queues processing data. And originally we were using something called Celery. Now, Celery is a lovely Python tool for connecting jobs together. You get this little, you get a RabbitMQ, you shove jobs into it, you get tasks and they run and things happen. And that's great until RabbitMQ fails. And I spent a lot of time at this point trying to harden RabbitMQ, replicate it, and it wasn't happening. And eventually I found Kafka. And this is how kind of my journey into Kafka started. And not in the best of ways, as back then Kafka was a bit more of a beast to manage than it is today. And we had no money to pay for people to help. So of course, we did it ourselves. But then as soon as we kind of got to Kafka, it was like, how do you build services on Kafka? And it became very quickly evident that you kind of wanted a bit more than this. And we ended up looking at Flink for a while. And this is kind of my intro to Flink. And it was basically known as, I don't want to touch Storm ever again, Apache Storm. So it was, what is this Flink thing? How does it work? Back then, once again, a beast. And we didn't end up using it very much, but I kind of kept with it and used it on and off in bits and pieces of projects as I went along. Fast forward a bunch of years, and I ended up working actually originally at Ivan, where we hosted Flink for people. And I kind of was part of the team kind of designing and how it all worked. And then I ended up at Ververica as field CTO, kind of like trying, because of, I saw Flink as that kind of increasingly as this answer to a lot of the questions I'd had as both an engineering leader, but then also as a data scientist and an AI user, that I needed something with those kind of guarantees that came with it. I wanted scaling. I wanted exactly one guarantees. And I didn't want to have to think about infrastructure in the same way.
Awesome. It's interesting as well, thinking about like Kafka and Flink kind of growing up alongside each other as sort of Apache projects as well. On that point around doing all things Flink at Ververica, what's it like working at Ververica, given that you guys are kind of the founding team behind Flink as a technology? How does that influence, being stewards of this open source project?
So, like a lot of these things, it's a bit of the ship of Theseus all over again, right? So Flink came out of the Berlin Technical University of a project called Stratosphere back in 2015, 2014 sort of time frame. And over time it grew up. And then Data Artisans, which became Ververica, was founded within a few months of Databricks, actually. Like bizarre parallel evolutions on either side of the pond. Except one got like San Francisco level investment and the other was very German about it. And which meant that Flink succeeded, but not in the same way. Flink is quietly behind the scenes everywhere. And where it's kind of coming into us is like, we have a lot of trust, particularly amongst the kind of larger organizations out there, because that's where Flink kind of found its home. There's a certain level of problem which you just needed to reach for Flink for. And we're often the people behind them, like some of the largest banks in the world, some of the largest credit card companies in the world. They use us because they need Flink for their problem, except they don't want to do it alone because it's not their core. Their core is solving the banking problems, the manufacturing problems, and instead they rely on us to handle the odd infrastructure requirements of Apache Flink. And that's kind of where we come from. So we have this kind of weird position of like I say weird because it's like a little different from like working at a kind of standard vendor, is because it's ours in some respects. It's very much that like we have a kind of position of trust which we don't want to abuse with the community. Like things like we still run Flink forward. We have no requirements for you to have worked anywhere to come to it. In fact, we deliberately try to keep it open. And it means there's a lot of community stuff we both maintain for the wider audience. And one of the most fascinating things right now is there's a great company called Confluent, the people behind Kafka, And they've done a wonderful job of making Flink loud again. Because Flink has always been that kind of quiet community of very hardcore data people. And now it's kind of seeing the big limelight it always deserved.
I think we're losing your audio a little bit there. But yes, I particularly like that point around like trying to build the space around Flink for people to come in and build stuff. Everyone's welcome, and like the joy of being a company where you're like, hey, we know how to look after Flink for you, and you can come and build cool things, and you can be opinionated about that without it necessarily being that like, hey, the only way you can use Flink is here, right? Which is super cool. That's one of the joys of being looking after these open source Apache projects, I guess. Obviously, we're talking a lot about Flink already, but for developers perhaps who listen to the show and are familiar with Kafka but haven't worked with Flink yet, what actually is Flink? And what can you do with Kafka and Flink together that you can't do with one of them alone?
So let's start with what is Flink. So at its core level, what Flink really is a series of actors, which were originally Akka, now Pekka. And on top of that is built a very large stream processing engine. So if you imagine there's a little actor at the bottom handling state management, state machines, and kind of coordination. And then on top of that is a big networking stack and then a job running stack. And what this does is you submit a job to a Flink cluster. The Flink cluster then makes what's known as a directed acyclical graph, or a DAG, if you're familiar with Airflow. And that is the processing graph of what happens. Flink thinks in terms of what's known as an operator. An operator is just a blob of code that takes an input and has an output. Everything is very actor kind of model thinking at the bottom layer, right? When you pass it messages, it does stuff, it passes messages on. And what that means is, like, you design a job, normally in a JVM language or in SQL or in Python, that gets compiled into these various operators and then distributed as a graph of processing on what's known as task managers. These are the tasks they run. Now, what that does is it means that like Flink takes records one by one and then distributes them by key or by other delimiters, and then does work on them. This work is anything from taking windowed times and saying how many people clicked my website in the last 3 seconds, 50 seconds, 6 years. There's no real kind of limitations, right? Or it materializes streams of data into something you can then like say, give me the top 10 users of this video game who actually who fell down off the edge of the mountain too many times. It was me. And this is where it kind of gets interesting. And where it combines with Kafka in a really interesting fashion is Kafka is, at its very core, an event broker. And an event in this case is an immutable fact in time. Data in Kafka is immutable. It records something that happened at a point in time and then gives you the ability to replay that at will. And what that means is you get a really nice way to distribute events around another distributed system of microservices. What Flink does is takes events and then does work on them, making data objects, materializing views, and allowing you to take actions based on it. It's not just analytical actions. For about half the people I know, it's actually transactional things like writing to a banking ledger, updating an actual number in a database, or sometimes even sending off things like push notifications. There's no real limitation because at its core, like Flink does anything you like. It runs near arbitrary code. So the answer is nearly always, can Flink do that? Yes, but should you? And the answer is nearly always, it'll be fun, have fun. At least from my perspective.
So is it fair to say then that Flink is this very flexible and elastic and scalable technology for building all of your sort of smaller services or data transformation layers or whatever, and getting that to work with a very kind of robust series of like, streaming data, maybe event data or transactions or data from a database or whatever, doing stuff with that and then putting it back into those kind of places?
That's a pretty good way to describe it. So Flink, to start with, is very elastic. It doesn't require much. You can literally have a CPU for the task manager, a CPU for the job manager, and you're done. Unlike a lot of the Apache Anhole projects, there's only 2 real node types in Flink, right? You can add there's one and maybe 1.5 more when you start adding the gateways. But like seriously, on most setups, you have precisely 2 node types, and it's a very, very small number of job managers and then task managers to do the work. So it scales right the way down, which most people don't realize. But at that point, it's like Spark. Spark takes a big chunk of data, does something, and puts it somewhere else. Flink takes a thin stream of data, but it can be n streams of data, and those streams can be quite thick, and just pulls them around, moves them around, manipulates them, and then puts them somewhere else. This is why it kind of often pairs so well with Kafka, because of that ability to take a stream, chunk it up, and then do work on it without having to worry about scalability is a huge win.
On that point of sort of pairing with Kafka, sort of like a fine wine to a piece of cheese or something, right? Let's talk a little bit about the actual technical integration. So what are the factors that you should consider as an engineer or a data scientist or a practitioner of these technologies when you're getting data from Kafka into Flink and vice versa in production? Are there any common pitfalls or sort of rookie mistakes that people make when they first start trying to get these two sort of siblings under Apache play nice?
So the main things to remember is it comes back to each of these technologies has their own kind of interesting pitfalls. And one of the major ones from Kafka usage I always used to try to teach people about was about committing offsets. At least in Flink, this is not a problem as it will handle these for you. So the big thing I would say about Kafka is turn off auto commit offsets, please. That at least gives you transactional consumption from Kafka. And if you don't do that, there'd be dragons. With Flink, your problems generally come in a slightly different flavor, which is that there are numerous ways to make Flink operators very inefficient. Certain key by processes generally have a parallelism of 1 because you have to key by the whole stream or the whole graph, which means you don't want to do too much at the same time. So there are certain function types you really have to kind of think about because there's no problem having more operators in Flink. There's no problem having lots of tiny Flink jobs that hop in and out of other data tools, whether it be a Kafka, a Redis, or even just files or data lakes, right? You can do that kind of bronze, silver, gold effect. But that's the biggest kind of gotcha in Flink land is too many tiny jobs or one ridiculous job. Right-sizing Flink jobs is actually possibly the main thing. It's like, do I put every idea I have into one big job that does absolutely everything for efficiency? And the answer is please don't. Or do I then try and do something else where instead I do something like I have like a bunch of small jobs that kind of chain together with topics or other message buses between them. And that, like the gotchas in Flink are pretty kind of clear on that front. Other ones which are kind of interesting are, what is a checkpoint? So checkpoints and watermarks are the real kind of like one of the core primitives of Flink. This is how you measure time. And it's like, do I then, because checkpoints are how we save our state in Flink. We say we've gone this far through at every point in the graph, and therefore we know that, therefore we turn the whole thing on and off, we'll start from there. Getting your checkpoints wrong or your watermarks wrong means most of the time your Flink job does nothing. Like it just won't start. It'll go, I'm good. Why? No watermarks. No, I'm not joining data. I'm good. And that is the number one gotcha in Flink, full stop. Using it with Kafka removes a bunch of gotchas in some respects because like the integrations are so well understood at this point that it's not so bad. There are a few there's the opposite of gotchas, which is quite interesting though, which is that there are some things people don't realize are true. So when you get to using Flink with Kafka, a classic problem in Kafka is that the fire hose mentality is very powerful. You just put everything into one very large topic. It's a very powerful kind of paradigm, but it also leads to issues. First thing I always say is please don't mix schemas. That way lies madness. And people still do it. It's such a mistake. But even if the same schema, let's say you have like a finance data going through and you have different tickers. So you have Apple, Tesla, Microsoft, Roblox stock going by, right? You want to split those out into their own topics. Now with Flink, what you do here is you actually use a serializer because your serializer says to topic based on. And that is just another function call in Flink. So you can write like literally 2 to 3 lines of Flink and it will arbitrarily splice a Kafka topic for you. And you can do that and it will handle the parallelism as much as you like. So think like little Flink jobs like this are actually what people don't realize are actually pretty efficient. You don't need to do massive jobs. That's the biggest gotcha actually in Flink is trying to do too much, at least at the start.
That's super cool. So yeah, watching out then for the old classic Kafka commit offset problems, making sure that you do go and set all of your Kafka broker and producer and consumer environment variables correctly and don't go suddenly butting into the soft stream of data and finding it crunch on performance.
Yes.
And the kind of the perennial problem, which seems to pop up in so many places of right sizing, right? It's like I want my my Flink job that's not too big or not too small, and finding that sweet spot. It's kind of reminding me of all kinds of segment size and compaction things in the past that I've run into.
Not as bad as all that. So this is one of the very useful things about Flink being elastic, is you can resize a job as you go. You don't have to, like, it will stop and then start again, but this is not a problem. Flink is completely okay stopping and starting the world as you go along, right? It's actually the way it scales up and down is by kind of restarting a job at a different parallelism. Now, that's really important because unlike Kafka, whereas changing the number of partitions is a task. And this is something you often have to get right very early on in Kafka land, is how many partitions today? And the answer is often more is a good idea just in case you need more, but less is much easier. And one of my least kind of happy facts about Kafka is how far you can get on a single partition is a number no one is really comfortable with, as it's so much higher than you think it is.
I've built so many questionable demos over the years that have been like, smallest possible Kafka broker, please, and we'll take it from there. And you can do enough to hurt yourself.
Can't you?
Yeah, it's
like yeah, and that's the trap with a lot of these systems, right? And this is actually kind of the onwards problem I find, is that these things were often designed in the big data, the birth of the big data era, the early 2010s, right? And like they came from places where things like spinning platter disks were more of the limitation than anything else. So like things like sequential writes were 100x faster than random writes and reads. They're still 10x, maybe 5x faster, but because the differences are now so different, to be honest, and everything is so much faster anyway, you have this interesting problem of like, what paradigms do we actually want anymore? And what are we still supporting just because we needed it a long time ago?
I think it's a question that we're seeing explored a lot in a lot of projects at the moment with things like, obviously we've spoken a lot about Discourse on this show before, with maybe looking at the expanding of things like Iceberg and table formats, and like it's that decoupling of things that before have ended up getting lumped together based on the constraints of previous eras, whereas now, like with everything almost exclusively being on the cloud or something that's orchestrated like the cloud with its on-prem, how those considerations change.
Yeah.
I think like I was gonna ask a question about like what does a well-architected Flink Kafka system look like, but I feel like we've kind of covered a lot of that.
Let's add a little bit more to that, because this is where we get into the interesting thing. Because like I have this kind of like I have quite a lot of opinions about Kafka, and as someone who's used a lot of Kafka and tried to convince a lot of other people to use Kafka, my general rule for Kafka is always to remember event broker, right? Its durability and decoupleability is why it's so damn powerful. It allows you to just say, once more with durability, have microservices appear, do stuff, and if they die in the process, no worries, the broker's got you. That's what Kafka does for me. But to make it efficient like that, generally, for my world, it should be relatively small. Retention periods max 1 day. Because like if you need to replay more than a day's worth of data, you generally have a very different problem than like I had some downtime. You generally have I might need to actually query it rather than just stream it back, either because it was so long between things they've fallen on random segments, has happened before, right? Or you don't want all the events because the volume is just so high you're going to thrash the system at the other end. So for me, this is where Flink and Kafka play so nicely together, is the ability to say, now let's write data over to something else, right? I would like to be able to, have a data lake, whether it's Iceberg, Hoodie, Paimon, or Delta, right? I want to stream things in. I got a Kafka topic. I filled it from many databases of CVC, maybe an MQTT broker, and I want to normalize that data down before I land it, right? So I'll write that through Flink. I'll use the fact that I can join across multiple things, denormalize stuff, that lovely Parquet file, and also handle that kind of compaction problem with small writes. And on the other side, I can use that as a hybrid source. Well, this is where I can use my data lake to hydrate my processing before I even start, and say, read from the data lake until we need to hit Kafka. And then we'll hit Kafka for the live stuff. this is where you get to what, in my opinion, the best architected systems look like, particularly with Flink and Kafka, is where you start looking to hybrid sources. Now, I'm kind of the big proponent of what's known as the data stream API in Flink, which is kind of like what I consider the primary API of Flink. It gives you near full control. You get to do things like hop around the operator graph. You write in JVM or Python directly. You don't have to deal with data in its structural format. It means you can just kind of go with what you'd expect in a microservice. But this is where well-architected matters, because we all know that schemas change, right? And one of the kind of, I think, misnomers in Flink is like when you start dealing with Flink's table API, that's great when the other side is a table as well. If it isn't, you have this weird impedance mismatch. So like data stream matches Kafka perfectly. But if you're in like dealing with tabular formats like Apache Flux or Postgres, use the table API. It might fit really well.
One thing I'd love to expand on a bit, because we're touching on a lot of different sort of technologies in the broader ecosystem for streaming more generally, like beyond just Kafka Flink integration, what developments are you seeing at the moment in the world of streaming and event processing that are you most excited about? You know, what's improving in terms of performance, ease of use, new capabilities? Like, where do you see things going?
So the biggest thing, ease of use has just shot up. Like that's like I bear no bones about this. Like as someone who suffered the early days of these and like tried to install Yarn a few times, right? Like there are various platforms out there I wanted to try but just couldn't get working, right? And I was just like, is it me? And the answer is yes and no. It's like you just didn't invest the 6 months required to learn this. These days, not a problem. Everything is Dockerized. Everything is single node first. Everything just works. Everything has a SAS for when you get bored and just need it to work. This is a massive upgrade for everything. It means that like there are now more tools to use. And like the other thing here is there are now lots more options. The biggest kind of mistake people make with a lot of these tools is assuming one size fits all, right? Like Kafka is a wonderful event broker. It is a terrible database. Please do not use your Kafka as a database. It is very amusing and I have done it before, but do not do this. It is a bad idea. That way lies some very interesting outcomes, but none of them are brilliant. Same way as you can use Flink as your only microservice storage layer. People have, and it is very amusing. And I will give a talk about this later this year, but it might not actually be useful. So the biggest change I'm seeing is it's actually more community focused again, which is people are now seeing these tools do more than they originally thought they did. So same way as Spark recently coming out with actual real time for a change, Flink is coming out with more kind of focused batch optimizations as we go along. And that kind of normalization and cross-pollination is what's so powerful. Like queue semantics in Kafka. I don't know how I feel about that right now, because that's exactly what I didn't want from Kafka. But it's really useful for those times where I'm like, but I have Kafka and now I need it.
We have a data architecture at home and so on, right?
Yeah, it's more like I can't. It's more like this. Like I've worked heavily on systems that sat either before or after Kafka to do the big fan in or the big fan out, right? I have built and unsold and architected many systems like that. And the idea of queues coming directly to Kafka, breaking some of the semantical goodness of Kafka, is kind of an interesting problem, right? Is it the right pattern to use? My personal opinion, there are better queues, but if you have to, it's great. And like, you know, dead letter topics, also not a fan, to be honest. Like if I can't read it off the Kafka, just log that message to something else and move on. You're very unlikely to be able to deal with the poison pill record in Kafka, right? There's no point putting it back in Kafka because now you've got to scan for it.
I have seen architectures out in the real world with dead letter topics that form little loops that go back into your production Kafka, and they go round and round like a merry-go-round of messages.
And yes. You end up with this on slow days, you end up with increasingly terrible topics, with increasingly bad records going round and round and round. And like this happens in Flink as well. It's not just a Kafka problem. It's like the perennial problem of what do you do when it doesn't work? And like we have to define failure. How do you accept that that record might just be bad? It's like, why? Well, cosmic rays hit the RAM at the wrong moment, or actually it's JSON and someone didn't terminate a string.
the perennial issue of like, oh, we're going to fix all of these bad records, but by the time we fix them, truly no one cares. Like this shopping basket is 6 months old. This is not. No one is coming back to fix this. Like, yes.
That matters, but this is where we come down to the kind of the most interesting problem with a lot of these systems is where they came from and where they're going to. So Kafka came from logging, right? Logging events into long-term storage to look across bigger amounts of records at the right time. And then it sort of became, how do I distribute data around data centers? Because it's such a strong primitive. But then we get to this interesting problem of like, now we're doing that. What guarantees did it come with originally for the data it was originally designed for versus what it designed was being used for now? And this is back to the kind of like a conversation we had offline about API design. And like, is the API even appropriate for this? Back to the queuing model, it's like, it isn't really a queue. It's still a log, please treat it as such, but it's an unindexed log. And then it's like with Flink, it's the same thing again, which is like, great, I can pull records one by one, I can fail them appropriately, I can do RPO 0. But do I want RPO 0? RPO 0 is slow. And like, am I going to pay for that? And this is where you have to kind of realize what you're paying for in a lot of these cases.
On that point of like what you're paying for, so I think we're speaking a lot here about like the sheer variety of different options out there, and this trade-off between like there are these big, well-established projects that will do lots of things,
yes,
versus perhaps younger, more specialized projects that will do one thing very well. For organizations considering adopting this sort of stack of streaming and stream processing and thinking about things in terms of events, do you have a kind of a framework for evaluating for times when, you know, Kafka plus Flink is the right choice versus perhaps other streaming solutions? What questions should teams who are mulling this choice be asking?
This is like one of the biggest questions I think we both run into a lot in what we do day to day. And like the first thing I'm going to state, and this is really important, is that the min size required for one of these systems is 0. There is no real min size. And this is one thing I want people to get away from, is this thinking, oh, I don't have enough data to make this worthwhile. Like, if your data is important, it is worth treating it like it is important. If it's so small it all fits in a single node of Postgres, that doesn't mean you're not having a read replica for it, right? It's like the simple idea of like small data being less important is kind of one of the biggest misconceptions we have. So the short answer is always start small. Start with that one Kafka topic for that one thing that absolutely matters, where you must have data between systems, right? Start with that one Flink job, which is doing that one thing on that one Kafka topic. Like, let's say pulling data out from your databases and feeding a Kafka topic, or taking data out of Kafka and building a data lake. Or maybe it's doing the aggregation. You always start with one and then you compose it. These systems are composable, like very composable. There's an open question, which is like, what do I program Flink in? Which is the biggest question people start with. And SQL is a reasonable starting point, but it's also kind of like a bit of a trap. Flink isn't just its SQL API. And like, yeah, it's JVM first and Python somewhat second. But the key thing to note is, like, particularly if you do have JVM work, and it can be any JVM language. Some of the biggest the biggest Flink usage I know is in Kotlin because of they're new and hip and cool.
Damn.
And maybe have a lot of Android developers on staff. You never know. Yeah, they are a social media company. But like the key thing here is that, like, if you can use it for something small, start there. But don't feel that you have to follow the pattern of what it is traditionally used for so much, right? Like, there are whole companies. I think Gold Sky recently published a thing about how they maintain their whole crypto backlog in Kafka because that's actually the only way they ever consume it. And there's no harm, which is actually can make sense. I somewhat disagree, but it makes sense. Same reason as like there's other companies who put their whole feature store for the machine learning pipelines in Flink because it's too important to let go of. It has to be running continuously. It has to scale horizontally and vertically. So starting small, composing the jobs. Don't just try and do one big bang and go. Put it in between things. Don't make it the only path. You can fit Flink over almost any system. Like, classically, it's build a data mesh. So make it build those data products for your Kafka, right? But start small and then watch it tier up. It very rapidly becomes the easy answer to anything where the data moves quickly, but it's actually even more valuable when the data doesn't. One of our biggest success stories in recent times was helping a bank move vSAM files around. So these are in ZOS, they are mainframe files. We are pulling them out, replacing a COBOL job, crunching them up, and then putting them back.
Incredible.
Yeah, putting them back. That was the number one thing. It's like an 8-hour COBOL job became a 10-second Flink job.
Oh, that's so cool.
I know. And it was just amazing to see because Flink can pick up files, no questions asked, right? And then also, some of those now go into Kafka as well and feed downstream processes. As like they were evolving their Flink and their Kafka separately and are now together. And this is where the strength of these systems come from.
I have some friends living in ZOS land that would definitely be very interested by that as a model. As always, I am blown away by like the depth of your knowledge on all of these topics. So thank you very much for humoring my questions. One final question before we wrap up, and I would keep you here all day if I could. What's your advice for developers who want to master all things Kafka and Flink? Where should they start, and what are some of the best paths for getting hands-on and starting to understand these technologies?
Well, if I can be cheeky, come to Flink Forward. It's in Barcelona this year, in October. That's the conference for all things Flink related. And yes, I am part of the team running it, but it's really about the community. That's the cheeky side. And the next thing here is like, go to the Apache Flink website, right? That's the place to start. There's also quite a good Slack attached. There's a pretty good Kafka Slack managed by the Confluent team as well, which I also tend to recommend. And these are just genuine places to find other people in the same kind of boat as you. The big thing to note is that there's no fixed way you have to come into this. You don't need a million years of experience. But like any system, which is of sufficient complexity that it runs all the banks in the world, don't expect it to be easy, but don't expect it to be impossible either.
Cool. Really solid advice. I am so sad that I'm at All Things Open instead of Flink Forward this year. I only found out about the clash a few days ago and I'm still sad about it. Thank you so much for your time today and for your insights, Ben. This was awesome. And thank you to everyone who joined us live for another episode of Get Kafka-Nated. Next time, we will be meeting some of the Red Panda team for an exploration into a whole other way of thinking about doing streaming with a Kafka-compatible alternative to the open source Kafka. So look forward to that. Thanks again, Ben.
Well, thank you so much for having me.
Cool. And see you all next time.